Hi Jayla.
Hi.
Do you know what we're going to talk about today?
Bitcoin.
We're going to talk a little bit about Bitcoin. Do you know what Bitcoin is? Tell me in 2 sentences what you know about Bitcoin.
Like an online place to store money, or like an online type of money.
Pretty much. So do you know how people currently hold their Bitcoin? How can you hold it? Because it's not something physical, right?
Yeah. On like your own account.
Like a Bitcoin account?
Yeah.
So it's a little bit different than bank accounts. With a bank account, you give the bank the money and they hold it for you. And when you go and show them like your account name, your like ID and your password, they know it's you, so they can give the money back to you. But with Bitcoin, it's a little bit different than a bank account. There's no place you can go where someone is holding your money for you. With Bitcoin, because it uses math, you have to hold the coins yourself. And the way you hold it is you remember a 24-word password, basically. As long as you remember this password, you don't tell anyone, no one else can take your coins because you have to use those 24 words to use your coins. But if you remember it, no one else can steal the coins from you. But currently there is a problem in Bitcoin because you're the only one that has that password. If you forget the password or if you lose the password somehow, you can never get the coins back.
Yeah.
There's no one you can go to ask to help you find your coins back.
Yeah.
Wouldn't it be cool if there was a way, if you forget your password, after a certain amount of time, the coins automatically go to a second wallet or go to your friends or your children?
Yeah. That's a good idea.
Hi Jaron. So we're going to talk a little bit about Bitcoin.
Okay.
Do you know what Bitcoin is?
I've heard of it, but I don't have too much, I guess, information about it.
Do you know roughly how it works? Like explain in a few words what it is or how do you think it works?
So I've like heard some stuff around the internet and just like I guess through voice, through my friends, and I've heard that it's obviously it's an online I guess cryptocurrency.
Mm-hmm.
I guess it's through the web or through the internet somehow that I don't fully get. And I know that you need like an encryption to access it. So it's supposed to be like some high tech, like like super hard to break or hack like code, so no one can just steal your money.
Yeah, that was a lot.
Yeah, and I mean you can use it, I guess, and you can use it to buy stuff. Like more places I've heard are accepting it, but I mean that's about it.
Yeah, well, you actually already know quite a lot about it. So, do you know how someone would hold onto their Bitcoin? What does it mean to own a Bitcoin?
So I guess my educated guess would be I guess you have the code would give you access to the Bitcoin. So that kind of makes sense to me with how it would work.
It's similar to what you said. So with Bitcoin, your ownership is a 24-word password. It's very, very hard to guess because each word can be one of 2,000 different words. So the 24-word password is very long, and as long as you remember that, no one has for 13 years, no one has ever guessed someone else's password. So as long as you remember that password, you can use that password on the Bitcoin blockchain to spend those coins or use those coins. So Bitcoin's security uses math, basically mathematics, which is what allows you to be the only one that holds your coins so that you don't have to trust anyone else. But currently there's also a problem where if you lose your coins or if something bad happens to you, no one can ever get those coins back. Whereas with traditional money like fiat money, if your money is in a bank account or if you have it at home, if you die, either your family can go and get those coins by showing them your death certificate, or you will have a will somewhere where you can show the court and then they will distribute the assets to the children, right?
Yeah. So I guess how would you be able to like fix this issue, or is this just gonna be a problem that'll like be around till the crypto like ceases to exist?
So it's a problem currently, but Bitcoin actually, you can use some code in Bitcoin. I think I found a way to fix that problem. My solution to this is that every time you send a transaction with your Bitcoin address, you automatically send another transaction which sends all of your coins to your children. But if they try to use that transaction when you are alive, you have a backdoor where you can cancel their transaction. But if you are dead, then when they send that transaction, you won't be able to cancel it, so the coins will go from your wallet to their wallet.
Okay, so you're saying that you would send the coins to your kids as just like a backup or a safety in case you end up like passing or something happens to you, and then when you're alive, they would need to ask you for permission to access those coins.
So every time you use your wallet, you would basically write a transaction from your wallet to, let's say you're going to the store and you're buying a phone. You would write a transaction from your wallet to the store, and then in Bitcoin you have to send, every time you use Bitcoin, you basically have to send all of your Bitcoins. So you would send, let's say you have 2 Bitcoin and you're buying a phone, let's say for 0.1 Bitcoin. You would send 0.1 Bitcoin to the store and then 1.9 as a change back to your own address. You know how if you go to a store and buy something with like $100 bill, and if the thing only costs $50, you get a $50 change. With Bitcoin, you always have to spend more than what you're paying for, so you get a bit of change back. So my idea is every time you get a change back, you automatically write a transaction sending all the rest of the Bitcoin from your wallet to your family or your backup wallet. And if you don't use your wallet for a certain amount of time, those coins will automatically go to their wallet. But if you keep using your wallet, then those coins will stay in your wallet forever and they'll never go to your children's wallet.
Okay, I guess I think that's a pretty cool idea, because I mean I could totally see like someone getting in an accident and like boom, there goes like 50 grand, and like, you know, whoever worked hard for, you know, just it gets like frozen. So kind of like that. I heard a story about like this guy who like bought like pizza with like 10 Bitcoins or something, and the other guy like forgot the password or something like that, and he lost like 50 million in like in I guess dollar value.
Yeah, there was there's been a lot of those stories. There was one guy, I can't remember, I think maybe he was in Britain or somewhere, but he had a few thousand Bitcoins in one of his hard drives, and then he had 2 hard drives that looked the same, and he threw the wrong hard drive into the garbage bin, and that hard drive is currently in a landfill of buried in tons of garbage, but it's worth $300 million. So what he's trying to do is he's trying to spend $11 million on 2 robot dogs to try to use those robot dogs to dig through all the trash to try to get back.
Wait, so is this guy, is he already a wealthy individual, or?
Well, he would be wealthy if he got the hard drive, but
he's got
if he doesn't have it,
11 million to fund those dogs, so is
I'm not sure where he's getting the 11 million from. Maybe he's
maybe a loan once he gets his 300 mil back.
Maybe he's taking out a loan to try to get the money back. Yeah, if instead of if he used my protocol, where after he put the Bitcoin into that hard drive, he also used a backup transaction at the end of the wallet that says if he doesn't touch that hard drive for 2 years or 5 years, it'll automatically go to, let's say, his wife's hard drive. Now he forgot about it. His wife will have the Bitcoins. At least it's not gone forever.
Yeah. So, I guess hopefully his wife wouldn't run off with his money. That'd be the only problem in that case. But I guess let's go. I was gonna ask something about that, because I thought it was all on like the web. So how come that gets stored on a hard drive?
Okay, so you don't actually store the Bitcoin on the hard drive. What you store is just a 24-word password.
Oh, like his password's on there. Okay, so technically the Bitcoins are somewhere in like, I guess, the Bitcoin universe.
Exactly. Technically, the Bitcoin are locked forever on the Bitcoin blockchain, and if no one can ever guess those 24-word password, or if he can never find those password again, they'll just be locked on that blockchain forever, and no one can ever use it.
Wow. Yeah, that's crazy. Huh. Yeah, that's a lot of money as well to just be like sitting away, doing nothing with. But That's cool. That's interesting. That's a good idea. No.
Hey Kody, nice to meet you.
You too.
Should I start explaining it first, or do you want to break it down first?
Yeah, sure. Let's just go to your document and then you can kind of walk me through it. Did you see the vault stuff that I sent you?
I took a look at it. Honestly, I'm not expert enough to fully understand it. There was also a YouTube video where they were talking about it. I think it's something like it's called like Covenant, and like there's a way to change the this is like, I sound like a noob. I think there's a way to make the wallet address so that you can only send it to certain other wallets or something like that. So that if
that's called transaction introspection, right? Which is to look at the internals of the transaction. And so the way that Jeremy proposes doing it is called op check template verify, right? And so op check template verify is that you're committing to a future transaction, right? And so for this, sort of what you're talking about here, the way that you would use that as a vault is that basically either there's a signature from a specific pub key, which is your pub key, or you commit to a future type of transaction. And that future type of transaction would be, if 2 years or so have passed, you can sign it with these different pub keys, right? And so kind of the same sort of concept that you're talking about in terms of the will, right? Where there's you can recover your Bitcoin just using your public key, but if you were to die, then after a certain period of time, a threshold of other people would be able to recover your Bitcoin, right? So Jeremy's been doing a lot of work on that, which is why I sent that to you.
Thank you so much for that link.
Walk me through this one.
Thank you so much for that link. Okay, I'll try to. So my will has a few different versions, but the first version is the most basic, and I believe a lot of Bitcoin developers already use stuff like this. It's the simplest because you don't have to do anything. It's pretty much automatic. You just change your wallet address from, normally people do like a pay to pub key hash instead of using that as your default wallet. You just make your wallet add an extra line at the bottom, basically, that says if it's been 2 years since you've last used this address, then the secondary private key can also be used to withdraw coins from this wallet, and that private key you would give to your child, or you would just get their wallet address and include that as that secondary link. And then the second version, solution 2, and if you want to scroll down, it's totally up to you. The solution 2 is the withdrawal time will be shorter than solution 1. Solution 1, because you have to renew your will basically before it's up, so you would set it to a longer time, maybe like 2 years. But then that means if you die, your child has to wait 2 years before they can redeem it. But the second will, you can make it much shorter. You can make it something like 30 days. It's a little bit similar to how hash time lock contracts on Lightning Network works, where if someone tries to cheat, you can use a revocation to take part of their coins or all of their coins. In this case, what you do is every time you send a transaction from your wallet, you then you sign a second transaction which you give to your child that he keeps, and neither of you upload this to the blockchain. So that's what keeps the second one also a lot cheaper than the first one, because this one you can use with your hot wallet. You can send 10,000 transactions. You can be spending coins from your wallet every single day, and that will, every single time you write that will, your wallet, ideally the wallet app should do that for you as simply as possible, so that you don't have to reconstruct the will every single time. Either you just type in your password and it signs it, or maybe there's a way for the wallet to automatically sign both the transaction that you are using to purchase something and that transaction after you buy something. The change comes back to your UTXO, and then you sign that UTXO and create a will from that change address to your child.
Okay.
So ideally, it could be automated to be even easier to use.
Yeah, are you familiar with Taproot yet? Or
No, I'm not familiar with that. I
that's
think
okay. Yeah, so let me just give you just a quick overview of the way Taproot works, right? So basically, you've got the Taproot address. The Taproot address is just a public key, right? Like a tweaked public key. And so over here you've got the keypath spend, and over here you've got a Merkle root for a tree of scripts. So sort of what you're describing, where you've got like all these multiple spending conditions and all those kinds of things. Taproot is a way that you can put all of these spending conditions into a tree, right? So all of those different scripts that you were describing, instead of having to do like a very long script, what you would do is you would say like, this is spending condition 1 script. This is spending condition 2 script.
I see.
This is spending condition 3 script, right?
I see.
And then, so basically the person who is running the wallet, or like the person who owns like the root public key or whatever, right? So he would have access to this key. And so he can just, with a naked public key, just make the payment, right? And then over here during these script paths, these would be all of the other spending conditions, right? And so those other spending conditions, like the stuff that you're doing here, where it's like, if check sig, else this, kind of in Taproot world, that's the, if when you do the spend, there's only one item on the stack, and that one item on the stack is a signature, then it's a pub key spend, right? If it's not, then you expect a control block, which tells you where in the Merkle tree what you're going to be proving that this script exists inside of that Merkle tree. It's like you're doing just a standard like SPV proof, if you've ever looked those up. But you're proving that this script was part of the address when you made it, right? And so I think this would be something for when you're looking at these sort of more complex conditions, where it's like, hey, else there's this thing over here, right? Because if you like what you're describing, where the person is going to be using this as a hot wallet, then every single time they spend out of that script, they're going to be revealing the script, right? Versus in Taproot world, every single time they spend, they're only going to be doing this check sig. So they only reveal what the key path is, and the key path is just for the key that was part of the address. Right?
I see. So with Taproot, you're also saving transaction fee, if I'm correct, because you don't have to reveal every single.
You don't have to publish the rest of the script.
You don't have to reveal all the branches. You just have to go as deep in the branch as you would need to complete the transaction.
Exactly.
That's really cool. Yeah, I didn't know that.
Yeah,
Thank you for teaching.
That'd be something I would look into in terms of the way that you would structure this, because this is specifically what Taproot is designed for, is that Taproot is designed for that there's a happy path spending condition, and the happy path spending condition is going to be you just doing a plain signature from the public key, right? And then there's the alternative paths, and you can do as many complex scripts as you want inside of here, right? And so like, for example, multi-sig doesn't work in Taproot, but what you can do is you could define, instead of like, if you wanted like a 3 of 4 multi-sig, then the way that you would do the 3 of 4 multi-sig is that you would have 4 scripts inside of here. And each one of these, this would be 3 of 3, where it's keys 1, 2, and 3. This would be 3 of 3, where it's keys 1, 2, and 4. This is 3 of 3, 1, 3, and 4. This is 3 of 3, 2, 3, 4.
Oh, wow.
Right?
I see.
So that's the way that you do multi-sig for that one. But when you actually reveal the multi-sig, right? So if you were going to do this properly,
you only reveal one of those.
Instead of
You only reveal the one you want to use. I see.
The way that you would normally do it is that you would actually do something called musig 2, which is like a way of doing basically adding off chain what the signatures are of 4 of 4. So if you can get everybody to sign off, then you just do the key path spend, right? And so now you don't have to reveal that it was a multi-sig. But in the event that somebody dies or whatever, then 3 people can go and they can reveal one of these script path spends and spend it out, right? So that's sort of, I think that just the way that you're describing this here, this is like precisely what Taproot is built for. And so just because like nobody's built out any of this stuff that you're describing over here, this is precisely the stuff that people were waiting for Taproot in order to start building out.
Yeah, Taproot was just introduced last year too. Like it's amazing how Bitcoin, like there's people in the world who think it's a dead technology. It's an unchanging technology. it's evolving faster than any other technology I can see. So yeah, that
Exactly.
what they say,
Right?
it doesn't make
So
any sense. Yeah.
that's the one that I would look at for Taproot stuff. And kind of the best Taproot info available that I've found is if you go look at Chain Code Labs has like a 4-part lecture series on Taproot, right? So I would go look at those. And also, if you look at the work that Jeremy's doing with Judica, he kind of, for a while, he wanted to do this opctv stuff, which is check template verify, which would be like a soft fork into Bitcoin of adding a new opcode and all that kind of stuff. And he's kind of given up on that one just because like nobody was willing to do the soft fork for him. So he's been trying to see how much he can get away with just doing Taproot, right? And so a lot of his more recent work has been focused on this problem specifically of how to do these sorts of spends, right? So that's one element of it. The other element of it I would see is that I think that the second solution that you're going for is definitely the model to go for, right? Because the thing that you want is for the person to be able to spend your coins out and then not just like have to wait 2 years after you die and then like, keep track of the coins or whatever. It's you want them to have to spend into an address, right? And then out of that address, they can only pull the coins if like, certain circumstances have been like hit, right? So the way that Lightning's doing that is that Lightning, you're not actually holding on to the key, you're holding on to a signed transaction, right? And so in terms of the will backups, like I think that holding that signed transaction is probably the way to go.
Yes, thank you so much.
Because if you're actually holding onto the key, right, then that becomes much more complicated to do. Right. Sort of the benefit of it is that you can dynamically add and subtract from that UTXO. Right. So like you can spend out of it, you can do whatever. Right. But the problem becomes that now the other person's holding onto a key. Right. And so if you just give them a signed transaction and that signed transaction can move the coins into, just like look up the Lightning spec, and in the Lightning spec, it shows the way that they have the script structured in terms of the force close. When it does that unhappy path, it pays into an address, and the only way to move out of that address is with a signature from a specific key that the other person has, right? And so I think that's the way to structure it, is that instead of them holding on to like the keys, they hold on to a transaction, and that transaction is what updates that. And then when you update the wills, it's what you're doing is updating that transaction that they're holding on to. Right. And so,
and allowing,
I think, because that's a way to get it working first. Right. And so for anything else in terms of like, hey, they spend out of this one and then they have to wait 2 years or whatever. And then once or whatever, it's just because we don't have transaction introspection, which is what I was talking about with covenants, which is that you need a way to look into the transaction to see what the spending conditions are of the transaction that they're trying to make. Right. So right now that's not possible. But what is possible is doing something like Taproot, where you have the key pass spend, which is that I can always move my own coins, or they can do this script path, and the script, the one that you've signed, like the signed transaction that they're holding on to, is the script path spend paying into that specific address. And that specific address is a different Taproot tree. And that different Taproot tree is there's a key path spend or there's a script path spend. And the script path spend for the second address that you're spending out of is just like, if they know a key, then they can move out of it, right? But if you but that'd be the way I think that you could attack it. So the second one or whatever is definitely, I think, the way to go. And then based off of this, just like Jeremy's work is definitely the one who's like really working on this the most. And then I think
Kody, you're doing all my job for me. You're doing the explaining for me. I was supposed to do more of the explaining, but thank you so much. If I can continue explaining, or if I can say a few things. Another advantage of letting your children hold the signed transaction is that they can hold it in multiple places and not be afraid if someone else finds that transaction. If someone finds their private key, they can steal their coins. But if someone finds the transaction, all they can do is broadcast it. So there's no risk of like that transaction going into the wrong hands. So what you can do is you can give a copy of that transaction to every one of your children or your spouse, anyone that you want to help you redeem that will. And as long as one of them is alive, they can just broadcast it. And then what if they try to broadcast it when you are still alive? Because let's say you went missing or something for 30 days, but you're not actually dead, and you don't want them to just redeem your will within 30 days. Well, as long as you are connected to the internet, you can see that transaction happen on the blockchain. And then what you can do is, there's a 30-day period where the children, after they broadcast the will, they still cannot withdraw the coins from the will yet. You have priority. Anytime, if you use your private key, you can take the coins back out of the will that's already on the blockchain into your own wallet. So, and then if one of your child is like malicious and they try to kidnap you or shut off your internet for 30 days, and then they submit the will, and they want to basically steal the will from you even when you are alive, by stopping you from using your revocation to withdraw the coins back out of the will. My solution to that is to give another signed transaction on my behalf to each of my children the same time I give them a will, which is called the will revocation. So at the same time I give each of them a copy of the signed will transaction, I also give them a signed copy of the will revocation. So any one of them can also upload the will revocation after the will has already been broadcasted onto the blockchain, to automatically revoke the will, the coins from the will back into only my address, because it's a signed revocation, meaning they can't change it. They can't use that revocation to withdraw it to a different address. So the benefit of that is, like, if one of your children is kidnapping you, if your wife knows, or if your other child knows you're still alive, they will just revoke the coins so that no one can get the coins from the will. It goes back to your address, and then now the child just realized he wasted his time, and now he gets arrested, of course. And then the next will I sign is not gonna have him in the outputs. He's not gonna get any coins now because he tried to kidnap me and steal coins. So that's how you can balance. I think, safety and also speed and cost.
Yeah. So just like kind of like side note of like the reason why I was kind of is like, this is stuff that's like been worked on, right? So I'm like familiar with all these concepts and trade-offs, right? So this is why when I'm telling you like these Jeremy things is like, this is stuff specifically that Jeremy's been working on for the last like 3 years, right? So like those trade-off models that you just walked through, that second link that I'm about to send you, is the inheritance scheme that for the vault that he described. It's basically the same thing that you arrived at, right? But it's like in code of like the way that he's working on this stuff.
Yes, right? I have to look more into that for sure.
Yeah. So, but like you're on the right track.
I've got a ton to learn.
This is
No,
so this is like you're definitely on the right track in terms of doing this stuff. But like of the two options, that you were going for, of like one of them is they broadcast the transaction, it's just locked for 2 years, right? Like that's like the wrong path, right? Like the correct path is they broadcast the transaction similar to Lightning. It's in a place where you, if you're connected to the internet, can publicly see it, and then you can do the revocation key on the Taproot key path spend, right? So like that's the one that I think that you need to like look for. This is like next steps for you, is that like take the model that you're moving, and that first control flow of the if statement of like the check sig public key, that's going to be your Taproot key path spend. And then these alternate spending conditions that you're describing are going to be in the tap tree, right? So that's the one to look at. And so this ones that I just sent you right now, those are like Jeremy's work specifically on this problem that he's been working for. And then did you look at ScriptWiz when I sent that to you?
I looked at it. One thing I couldn't figure out how to do is really, really basic. I couldn't figure out how to create a signature for a private key that it said is correct. Like I went onto the Bitcoin
did you look
blockchain.
At the signature tools?
Oh, I'm not familiar with it.
So if you just go on ScriptWiz,
yep.
That was, so let me just share my screen with you, and then I'll just show you how to do this. So if we go here and I do my desktop one, share. So this is ScriptWiz, right? So there's a couple, it's kind of complicated, but like once you figure it out, then it's actually not very complicated. But so if you go onto here, right? If you go onto here, then up in the top, he's got these like different tools, right? So one of them is the mask tool. The mask tool is for Taproot. This is the signature tool. So if you click signature tools, it lets you put in a private key, a public key, a compressed public key, right? And then from here, you copy these down, you put the message in that you want, and it'll generate the signature for you.
Oh, that makes
so much sense. And then it'll do it in DARE encoding, right? And then here, it'll take that stuff and convert it into hex for you, right? Something else that's just very useful about this is that you can do ECSA and Schnorr. When you're doing Taproot, it has to be Schnorr, right? And so I have a thing online that I posted a while ago explaining like differences between ECSA and Schnorr. I think if you just look on the Fediment and the Fediment Discord, I've got it or whatever, right? So then he's got like these other tools on here too. The other tools to look at are this one, the Wiz data tools. So this one, as you're building transactions, like this gives you it in bytes, in binary as the number, the SHA-256 of it. Like this is little endian, right? So like as you're building Bitcoin transactions, you have to be like flipping the endianness back and forth.
Yes.
So like this is the tool that everybody uses for doing this stuff. And then the last tool for it is for Taproot, this mask tool, right? So see where I was talking here, this like inner key. So this is the public key path spend, right? This one are the different leaves that you're doing. And so what you do is you build the script in ScriptWiz over here. And then you take that ScriptWiz thing and then you, where you go? So you like compile your script and then you add it over here and you can add the different leaves. And then once you add all the different leaves to it, then, so let's go back over here. Let's just switch this to Taproot. Right, so for this one, compile your script.
Yes,
right,
I understand what you're saying.
Yeah, right. So for
you
this
can
this
combine
is like
you can combine the transactions into a master Taproot address, basically using the leaf.
Yeah, so
tool.
MAST stands for Merkleized abstract syntax tree, and what you're doing there is that's building the Merkle tree out of those different ones, right? And then once you're done with it and you do the compilation, then it'll also give you the control block. So the control block is the way to get to the script within the MAST, right? And so those are really important. And so I think that Barack, if you go look it up, he'll have he'll have like a couple different videos explaining how he uses ScriptWiz and how to do that stuff. Barack's the guy who broke LND, if I don't know if you were tracking that, right? But the way that he did it was using this tool, right? Where he built a 998 out of 999 multi-sig, and he broadcast that, right? And so that violated SegWit V0 spending rules, but it didn't violate Taproot rules, right? And so for BTCD, which is the Go implementation of Bitcoin Core that LND uses, they made a mistake when they were doing it because they were like, hey, this violates the SegWit rules, but it's not SegWit rules, it's SegWit V0 rules, right? So when they were doing the parsing. But yeah, so I would just go check him out. He is, if you go on YouTube and look up Rock ScriptWiz. There, this one, this like liquid script wizard with Barack, that workshop. It's like a good one where he explains this stuff.
I will definitely watch that.
And then if you just look up ScriptWiz separately, he kind of explains this stuff. ScriptWiz.
It's okay. I can go look for them and you can.
Yeah, just look at this one, this liquid script wizard with Barack, right? Because he normally works on liquid stuff, but if you look at his ScriptWiz tools, you can change them to pay to witness script hash or pay to Taproot.
Yeah, I have so much to learn. Like I don't know anything about liquid. I just started learning Taproot from just now. You teaching me. You know what I find is amazing about Bitcoin? I think the operations, there's like less than 50 of them in total. It's a Turing incomplete language, but we are still discovering ways to use it every day. It's amazing.
You go to Bitcoin script. Bitcoin script. Yeah, there's a lot more than 50, but
okay. But the commonly used ones is probably something around.
Yeah, I mean,
it's just not
like 5,
that many.
Right?
It's so few.
Yeah, there's more than 50. It's like, look at all these. You got like these splice ones, right? So see these where he's like disabled, right? So like these are one of the things where like if you got opcat and brought that back in, then you can do all sorts of stuff, like all sorts of fancy things. But the reason why these things were disabled was because during the early days, like somebody found an exploit for each one of these things.
Okay.
It's like, oh, if we're doing like even this one, just like op and, right? It's basically like, do you know how to do like SQL injection attacks?
Nope.
Basically, you can do like SQL injection attacks using this thing, right? Where basically instead of a private key, instead of a signature from a private key, you just do op and. So it's like, so SQL injection attack is like you're reading JavaScript, or like your JavaScript is reading like a string that somebody inputs. And so that's going to take that string, it's going to input into your SQL database, right? But let's say that the string that you're doing is like an end of line comment, and then and 1 equals 1, or 1 equals 1, right? Like the big one is or 1 equals 1.
Yeah, then you could just
And
ignore
then
the first
on
part.
comments, then in the sequel will read the first part of that, and it'll say like this, or 1 equals 1, then execute my attack.
I see. So
Right?
you can kind of like
So-
add extra code, and you can add backdoors to your code.
Yeah, so you're putting in your attack code, and the attack code is implemented because the truth statement is statement or 1 equals 1, and 1 equals 1 is always true, right? And so then it executes the attacks code after that. But there was basically ways that you could do that with Bitcoin, where if you're doing like op and, right? So it's like I basically cancel out the script that you were analyzing early, op and this thing, op or 1 equals 1, and then the other one, right? So fun stuff like that. But yeah, so see, look at all these things. Like, these are like all sorts of stuff.
Are they adding new? How do you know like roughly how many new opcodes they're adding per year? Because I think there used to be less.
Yeah, the ones to pay attention to are if you go look at sig hash, any pre-vet. Oh yeah, it's a sig hash. So for this one, this explains just kind of like at a high level, sort of like the next steps for Bitcoin development, right? In terms of like, these are the soft forks that need to happen for us to do all sorts of cool stuff, right? Like, so for example, here, let me just send this to you. Over here, like L2, this is like a new version of the Lightning protocol. And the reason why this is going to be better is because, for like the previous version of the Lightning protocol, you have to keep all of the old transactions so you can do the revocation keys and stuff. Is that basically for any previous output, right? Is that it doesn't matter what the output that you're using as the input is, as long as it satisfies this condition, then that output's good to go, right? So now all of a sudden, any previous output can be any of the previous Lightning channels states, right? So now you don't have to keep all of those Lightning channel states. You only have to keep the most up-to-date one. So now the database size for a Lightning channel goes from like a couple megabytes per channel down to like a couple bytes per channel.
Wow.
Right. So that's like a order of like that's like a 3 order of magnitude improvement in terms of the database stuff for it.
That's amazing. And I actually read a little bit about this. It also fixes the problem of if your wallet is bugged and you accidentally broadcast an older commit, this solves the problem. You can just rebroadcast the newest commit and you don't get penalized. You just write over the old one, right?
Yeah, so you can't broadcast the newest commit, right? Because the fees have to be different, right?
Okay.
Because it's replaced by fee, right? So the fee has to be higher on the new commit that you do, right? But for the big one is that you're not even going to hold on to that old transaction anymore.
I see.
Right. So that
sense.
old transaction, you can just get rid of it. Right now, there's like gigabytes and gigabytes of toxic waste of just Lightning channels, the states that you don't want to hold on to, right? Yeah. But so if you look at these, for any pre-vout, he goes through 3 or so different ways that you could implement any pre-vout, where he basically needs from Liquid, you need like op check sig from stack and op check template verify. If you have both of those, then you can do this. If you have, there's like 2 other alternatives, right? But basically, if you get like 2 of these liquid opcodes plus 1 other change, then you can get this stuff, right? But there's like 3 different paths that you can go down. And the guy who wrote the paper for this, Christian Decker, he, well, I think Rusty is also a co-author on this. But if you get like either of these things, right? And so here's a thing for you for this Bitcoin vaults. So here's one, I'll send this to you, is that this is a way to do vaults with any pre-vout. So there you go. Cool.
Well, thank you so much, Kody. I'll definitely dive more into all of these things. Okay. You've taught me a lot, and I hope to be able to learn more from you in the future.
Yeah, totally. If you're in a problem, just shoot me a message.
Okay.
All right.
Nice talking.
See you, man.